Hey guys, back with a new video. This time I want to show you a new Houdini node tree, but I'm not gonna do it from scratch. I'm kind of just gonna run through it. Right here we have an HDA, which is basically this sort of this diner table, and I'm going to show you how it works. We have some couple of settings here that will just allow me to adjust different effects, like if I want it to be a bit smaller on the x-axis or a little bit longer on the z-axis or whatever. I could change it that way. We could change the curvature, and make it much more rounder. We could also reduce the curvature and make it much sharper on the edges. We could reduce the smoothness. If it's a game, you want to keep the poly count low, you could do that, or just really ramp it up if you really want to. You have this table thickness, which is kind of gonna do that, which is a bit crazy. Let's just kind of do that, undo that. Or you can reduce the table thickness to be 0.05 to be half of this if you just want it to be a bit smaller. There are some other settings, like you see this rim setting here. Because this is a diner table, I wanted this like metal rim thingy, and you can increase the smoothness of this by having more points, and you could reduce the scale so it's not jutting out as much. You could increase this. Okay, so this is the gap here. So there's a small tiny little gap here, and we can increase this size just a teensy weensy bit. It's quite large. It doesn't make sense this way. It's supposed to be a bit smaller than this, so we can make it twice as big, so we can increase this gap if we wanted to. We can increase the smoothness further, and there's a bunch of things we can do with this. Okay, I'm just going to reset a bunch of these things. Then we also have the ability to adjust the leg length. So if you would increase 1.5, you want it to be 1.5 feet taller, 1.5 meters taller. And then if you want it to be smoother, like low poly, you can see it's low poly and it's kind of jagged. We can increase the poly count and smooth this out. We can increase the radius this way and that way, so it's like we can really adjust the radius in both dimensions. So we could have something like this if you so desired. A couple of different settings here. We can reduce the poly count so it's more jagged if you want it to be a game thing, or really high if you want it to be more representative of some film asset or something. Okay, and you could also change the shape of the leg. Okay, so you can see here that we are using these points to alter the shape of the leg. Okay, really change, and we can just add a new key point, change things the way we want. There's a million options available. Oh, and there's also this leg scale cross section, so we can just kind of scale the leg up and down a little bit. So we can just a global scale thing. By default I kept it at 3.6. Now I'm going to show you how I did this in Houdini. Let me show you how I did it. Okay, here we are in Houdini, and this is the asset table here, and let's dive into the HDA. It's a little long, but it's really not that complicated. Okay, it's pretty easy. Let me show you how it's done. So we start off with a simple curve object, which is basically a polygon curve, which I just drew a square shape, a rectangular shape. You can see it's just a rectangular shape. Okay, and then what I did was I transformed it. This transform is really just to give me control over its size, so I can scale it X and Y, so I can get the shape. And then I reversed it, get the sort of scaling in Unreal. Okay, and then I reversed it so it's pointing upward. And then what I did after that is I created a poly bevel node, and I beveled just the points. I set the poly bevel to a group type by points, and I adjusted the distance and the divisions. The distance and divisions are all controlled by the HDA, so you can control the number of points with the divisions like this, and we can control the distance, the amount of beveling with this. At this point the node tree kind of breaks into two. Let's just follow it vertically first and we'll come back. The next thing I did was I took this and I extruded it out. Now it looks a little weird. This is not how extrusions usually work. Usually you would see an extrusion that looks like this, and this makes a little bit more sense, especially in Houdini without the back face. What I did was I outputted the back face so I could have this bottom piece, and I disabled the output side button right here. And by doing that, I am able to sort of create two pieces, the bottom piece and the top piece. So let's go further. The next thing I did was I created a group which groups all the points in both of these, and I called it outer points. It's just a base group. I just added a group node, kept everything on at default, just changed the group type to points and named it outer points. I need this for later, and I'll explain this later. Okay, then what I did was I went for another extrusion, but this time a poly extrude node, but instead of extruding, I simply inset just inset it slightly so I could create this gap. You can see here I just create this gap. I also created a in this poly extrude node, I created a group, so there is a ability to output the side. Okay, we make sure that this is enabled, and we enable the side group, and we label it rim_uv. Okay, I'll explain why I did this later as well, but remember that we just outputted this side group. We created a side group and we call it rim_uv. Okay, and then what I do is I simply use UV flatten, which would work really well for this kind of shape, which just flattens the geometry in the UV. And then I used a UV layout node, okay, which you can see here when I click the edit mode. It just shows me how it's laid out. Okay, so I laid it out on this corner. All right, very cool. Then the next stage is let's go back up the tree, because we now merge with the other side. We were originally here, and then this kind of split, so we know what happens when we go down this line. When we go down the other side, what I did was I took this shape and I transformed it and rotated it so that it faces the Z direction. Okay, you can see here from this little gizmo over here, it's facing the Z direction. The reason is because I want to use this as a profile in a sweep node. And what am I going to sweep? I'm going to sweep this line. I created a simple line. You can just see it here. I give it an attribute called thickness. I'll tell you why I did this later. Okay, I give it an attribute called thickness, and I simply give this attribute 0, a point attribute, by the way. Okay, and I just put it at 0. And then what I did was I use an attribute wrangle node. Okay, so for those of you who are not familiar with Vex, it's very intimidating in the beginning, but I'll try to explain what I'm doing here slowly. But just for your knowledge, you can visit this website called Joy of well, really it's called Tokeru, I think, tokeru.com, and they have a series called Joy of Vex. It's a 20-day program which kind of short exercises on how to learn Vex, but it has really helped me understand Vex better, so you can kind of learn from here. Okay, back to Houdini. What I'm doing here, I'll just display the points and I'll display the numbers. You can see here what I'm doing is I'm taking the position. What the attribute wrangle node does is it runs over every single point. So it says do this code in this point, and then this point, and then this point, one after the other. Okay, starting from 0, ending at 16. So it takes the position, the x value of the position, remember the x value is this direction, and it takes the position of this point, and then it says that's equal to the sign of the ptnum. At ptnum is an attribute that basically means these numbers 0, 1, 2, 3, 4, 5. So that's what at ptnum is, and multiply that by a channel scale, which I create a spare parameter here. Okay, you can, if you just type ch bracket and just type a word in these quotations and then press this button, you'll create a spare input here which you can control. Okay, so you could think of it as sine 0 multiplied by 0.007. Okay, so what's happening is this is sine 0 multiplied by this, by the scale, sine 1 multiplied by the scale, sine 2 multiplied by the scale, and as you can imagine, if you know anything about how sine waves are, it will just generate a sine wave in this x-axis. Okay, and that's what I want. I want this S shape, this sort of curvy S shape, sine wave shape. Using this curvy shape and my previous rotated table thing, I use a sweep node and I create this rim shape. Okay, and you can see here this rim shape is actually following that S shape. Okay, so basically it's just sweeping this line along the shape of this table piece. Okay, and because the line has been curved in an S shape, it takes the form of this S shape, which is very convenient. Okay, I'm also enabling through the sweep node, we can enable compute UVs. I don't really do anything else. I also enable reverse cross sections, because when you use a sweep node, sometimes the cross section, it's inversed, you know, the normals are on the wrong side. So I just click reverse cross sections and the normals face the correct side, and that's it. Okay, and then we move to the next section, which is the next node, which kind of just transforms and rotates this to be back to the original orientation. And at this point I make a small group. I call it rim outer points. It's a point group. I just create a group node. I change the group type to points. I name it rim outer points. I disable the base group. I enable include by edges, and I enable unshared edges. When you enable unshared edges, what it's going to do is it's going to find every edge that has only one, that's only connected to one edge. If you look at this edge is only connected to this primitive. So you can see here, this is one primitive, this is another primitive, this is another primitive, this is another primitive. So this edge is only connected to one primitive. Okay, whereas this edge is connected to two primitives, this one and this one. So this edge it's shared by two primitives. The unshared edge is the one that's only not connected to one, so it's not shared by two. And this is an easy way of getting the boundaries of any shape. Okay, so I use this to group this boundary because I need this for later, and I'll tell you why. Rim outer points. Okay, similar to what we did earlier with the outer points on the other group. Okay, and then I use a match size. And what I'm doing here is the match size is a node that allows me to adjust the position of this object relative to another object. So if you remember this object right here, this is currently in a specific position that I want it to be in. I use the match size and I connect this up to the first input, which is the geometry we are going to move or resize, and the second input is the geometry we are going to use the bounding box of this geometry, and you can see it in purple, to adjust the size to. And I just say center to same, center to same, center to same, so that it makes sure that it moves this geometry to the correct position. Okay, before it was down here, now it's up here. Okay, or rather view this and template this, you'll see that it's perfectly aligned. If I template this, I have moved it to the correct place. Great. Okay, and then what I do is I do one last group, and this time I take the entire base group and I call it rim UV. You might remember that we already did that in this poly extrude with this side group, rim UV. We create this rim UV. I'll tell you why we did this in a bit. Okay, before that I just do a UV layout to make sure that we're not, you know, laying this out of the whole UV. Okay, it's automatically laying it out in one specific section. Great. Finally, we merge these two results together. Okay, we merge the result of this one and this one, we merge it together and we get this shape. But remember, they're two separate objects, so they're not combined. There's a gap between them at the bottom and the top. Okay, so the way we fix this is we use a fuse node. But if we just simply use the fuse node, it might actually fuse the wrong geometry together. If I were to just remove these groups, you'll understand what I'm talking about. Okay, sometimes it'll disrupt the shape. So to prevent that from happening, I have, just take a look again, destroying the shape. Okay, so to prevent this from happening, what we have done is we took this, this group, the outer points, and we have this rim outer points. We have these two groups, so we make sure that the fuse only works on these points. So it's only working on the rim outer points and the outer points of the table, and that makes sure that only those two groups are being fused. And then what I do is I create another group, and this group is basically just using the rim UV, which we have already defined over here and over here with the side group, and that kind of combines these two and allows me to define some effect on this whole thing. And the reason why I picked this section is because I want the table to have a little bit of a rim that goes inside, and the table is sort of inset inside the rim. That's important for this aesthetic that I was going for. So that's why I combined it in this group. Okay, so I just created a group that has rim UV, and that's it. And now I use a split node, which allows me to split based on a group, and I use this rim group as the basis. So now I'm able to split this group. So I have on the first input the rim, and on the second input, if I just invert the selection, you can see it, the table, okay, separately. So let's see what we did to the first input. It's very simple. I just added a normal just to make sure that the normals, if there's any problem with the normals, it's sorted. I added a Unreal material so that we could assign a material in Unreal, and I dropped a null node just so I can reference this later if I need to. Okay, nothing interesting happening here. When it comes to the table, I did a small change. Okay, the only change I did was that I took a poly extrude and I inset it slightly. You can see when I disable the node how much I'm insetting it. It's really small. Okay, and then I outputted an extrude front group. Extrude front group means this inner piece, the front piece of the extrusion or the inset. This is the inner piece, so this is the front group. And then I use the next node, and I only extrude the extrude group that we created here, the front group. So I'm only extruding this. If I were to delete this, you'll see that the entire object gets extruded. That's not what we want. We only want the inner piece to get extruded so that it extrudes down a little bit. And then I repeat this operation, but this time I'm creating a new extrude front group, and I extrude it, I inset it slightly. Okay, and then I again repeat this operation using the front group yet again, and this time I extrude it up again back the same distance, so that I've created this sort of gap. And to make sure that I have some control over the gap, I have a channel that controls this from the HDA. So I can control this inset, which will basically just control the gap. And then I add normals to this just to make sure that there's any normal issues are sorted out. I add Unreal material as a null node. I create a null node so that I could reference this later. And then what we do is we merge these two outputs together, and then we can fuse it because these 2 points were originally fused anyway. So if we fuse it now, it will be perfectly fused correctly, even with a very tiny distance on the fuse. Great. So that's the top part of the table. Now we got to work on the bottom part of the table. To work on the bottom part, or the leg of the table, nothing complicated, just a simple line, as you can see here. And we also take a circle. I added the circle in, and the circle we can control the radius of the circle and the divisions. This will kind of control the resolution at the HDA level, and the radius, as you know, can control the radius of the circle. And then what we do is we do a sweep, but before we do a sweep I need to make sure that this let's just template the table. As you can see, the table is down on the level of the floor, but the line is not aligned properly. So what I do is I use a match size again. This node allows me to make sure that I match the size and positioning of the line with this object's bounding box. So what I've said is justify the maximum point of the line, which is the top point on the y-axis, to the minimum point on the table on the y-axis. So it just makes sure that it just aligns it in this way, and that's perfectly aligned in the center already, so no problem there. And this helps me align the line to the correct place. And finally, what we do is we take this output and we use a sweep. Okay, and you might wonder, why is this shape looking so crazy? Let me just go back here and disable this setting for a moment. Okay, just so it's easier to understand, we have this circle and we have this line, and when we sweep it we create a circle with based on the line we create this cylinder, because we are sweeping the line along the shape of the circle and it creates a cylinder. We enable end caps using a grid type. I do enable a special feature. One thing I do is, of course, I reverse the cross sections to make sure that it's facing the correct side, and I use a feature called the scale cross sections. This will allow me to make sure that it's not too small. Okay, this helps me kind of sort of overall scale things. It's just a convenient way of doing this. This is about the overall scale you saw earlier, and I also enable something called apply scale along the curve using this ramp. Okay, by doing this I'm able to use this ramp to adjust the shape of this sweep, like scale this shape along the line, so you can have the maximum point here, and you can see, okay, we can't adjust it here because it should be adjusted here, just to demonstrate. So you can see we can create a lot of interesting shapes this way. And then I just apply normals just to make sure everything is fine, and I apply Unreal material and I drop a null, and this kind of helps me reference it later. Okay, and finally the last step is to merge these two outputs together, the output which is the full table top piece and the leg piece, and we merge it. Now there's one last setting I want to do to make sure that it renders correctly in Unreal, or rather helps with placement in Unreal, and that is to use another match size, and this time I'm not using any input. I'm just matching this to the world itself, and I'm saying justify the Y position, the minimum position of this entire bounding box to same, which is basically the 0 level. And this helps us align the table to make sure that it is in the 0 position in Unreal when we finish our HDA. And that's it. And once we've done this, it's just a matter of adding some of these parameters. It's just a matter of adding these parameters to our HDA, and we're good to go. And we've created a really robust, highly customizable diner table. Now, I encourage you to try creating your own version of this table. You can probably try to follow along by pausing the video and seeing what I've done. This might be a bit hard for you. I myself struggled to create these kind of shapes for quite a while, and it's only now kind of coming to me. So if you're a total beginner, try something simpler, like just one aspect like at a time, and that'll probably help you a lot. So that's all I had for today, guys. I hope this helps. Thank you for watching till the end, and I'll catch you in the next one.